This is topic 8-9, and it deals with radian measure, which is that button that we always told you don't let your calculators be in radians. Make sure it's degrees. Now you're going to learn what radians is. Radians is used because it can be made into a decimal and is easily used by engineers and programmers and can be put into uh, the computer very easily. So once you get into pre-calculus, that's all we use is radian measure and any math above that. All right, so the first thing we're going to talk about is the distance around a circle. So let's look at this. This distance around the circle is known as the circumference of a circle. And if you will remember, it's equal to 2 pi r, or 2 pi times a radius. Okay? All right. So I need to define to you what this is. This arc length is just a simple fraction of the whole circumference. All right. A radian happens when the length of this radius is equal. I could lay that radius there and I get an arc length that's its same length. Then we say we have a angle that is 1 radian. So the arc length, or the amount of rotation, forms an arc that's the same length as a radius. So if you think about that, how many radiuses would fit all the way around this circle? Well, the formula for circumference, that's where it comes from, is 2 pi radiuses fit around any circle. So all the way around a circle, we know as 360 degrees, equates to 2 pi radians. So if I went halfway around a circle by dividing 360 by 2, that would equate to halfway around a circle being pi radians. If I divided 180 by 2 and go to 90 degrees, that would equate to pi over 2. And those are the numbers we're going to use. These pi numbers are going to be our radian numbers that are going to help us define angles. Okay? All right. So first thing we're going to do is we're going to put our measurements on in radians on this circle. So this is still 0 radians. Okay, remember 90 degrees was pi over 2, half a pi. If I add another half to that, that's going to give me a whole pi for 180. I add another half, that's 1.5 or 3 halves pi. Add another half is going to get me to my 2 pi. So the question is, where does 5 pi over 6 and 11 pi over 6 lie in what quadrants? Okay, well, I need to think of my circle in terms of 6. So I'm going to take my blue pen and go back over it. 0 is still 0. All right, if I change pi over 2 into 6, it would be 3 pi over 6. If I changed 1 pi into 6, it would be 6 pi over 6. If I changed 3 pi over 2 into 6, it will be 9 pi over 6, because I'm multiplying the top and bottom by 3. And then 2 pi into 6 would be 12 pi over 6. Each of those little blue fractions you see reduce to the red fractions. So that makes it really easy now to find out where these angles are. Notice that number 1 is positive, so I'm going to start with my initial side, and I'm going to rotate counterclockwise. And I need to go to where 5 pi over 6 would be. Well, it's going to be past the 3 pi over 6, but not past the 6 pi over 6. So this angle is going to end up in quadrant 2. The next one I want to try and find is 11 pi over 6. So I'm going to again start on my positive x-axis. I'm going to rotate up. Since it's a positive angle, I'm going to go past 3 pi over 6. because I'm trying to find 11 pi over 6. I'm going past 6 pi over 6. Keep going. Even past the 9 pi over 6, but not past 12 pi over 6. So there's my angle. So it ends up in quadrant 4. All right. So that gives you a little taste of what radians are. In our warm-up tomorrow, we'll be working with negative angles and uh, finding angles that are coterminal to this. So the only hard part of this is that you've got to deal with some fractions. But that's not too bad because the fractions are pretty easy, the ones we deal with. Okay, see you on the flip side.